Assalamualaikum warahmatullahi wabarakatuh and have a good day. I'm Azrol bin Jailani from Jabatan Kejuruteraan Mechanical Polytechnic Port Dickson. Today, I would like to present stress intensity factors of an embedded crack near the surface of a solid bar. Solid prismatic shaft is the main component of mechanical structure used to transmit continuous power which undergoes under combined loading. Failure of solid shaft can lead to human hazard. This is my content for presentation today from the introduction until the recommendation. Okay. Stress intensity factor can determine by two solution, analytical and also numerical. And then for the numerical solution, we can use finite element method and boundary element method. And for my study, I will like to use a boundary element method using BZ software. Mode of stress intensity factor, we have three mode. Mode 1 opening mode, mode 2 sliding mode, and mode 3 tearing mode. Why we use the boundary element method? Because the less data preparation solution is exactly and fully continuous, use a lesser number of element and nodes, and only calculated on particular node that affect design analysis. But the disadvantage of a boundary element method is mathematical formulation in boundary element method is unfamiliar. The interior must be modeled in the non-linear problem. Boundary element method is resulting unsymmetric and fully populated. Most of the solutions are available limited to simple loading case such as under either of tension, bending, or torsion. In practice, however, engineering components on structure are often to subject to combined loading, which is turn cause mixed mode fracture too. Mode 1, 2, and 3. In these cases, calculation of stress intensity factor become more complex. Evaluation of stress intensity factor under combined load have been interesting research topic worldwide. Some methodologies and techniques have been proposed by researchers. To update the relevant finding in this respective field, the objective of the research are stated as follows. 1. To evaluate stress intensity factor of embedded crack in prismatic solid bar subject to bending and torsion loading. Then second is to compare effect of different loading, pure bending, pure torsion, and combined loading. Combined bending and torsion loading on the stress intensity factor. For this research scope and outline, stress intensity factor of the embedded crack near a prismatic solid bar near surface under constant amplitude bending and torsion loading are evaluated. The stress intensity factor are only calculated at the initial increment. In this work, all the analysis are carried out by using the boundary element software package of BZ. An elliptical embedded crack is introduced inside a prismatic solid bar for the three different crack orientation. ASTM, rough alloy ZK68T5 are used in this work. This is my methodology. We have a combination of loading acting on the prismatic bar. Okay, material ASTM rough alloy ZK68T5. Modus yang 45 gigapascal V0135. The schematic of the crack model are illustrated in figure. The crack introduced near a solid surface 77.5 mm, 150 mm, and 50 mm XYZ position as figure 3.5 and figure 3.6. A pure bending load 50 megapascal and 100 megapascal as figure 3.7 and figure 3.8. Pure torsional load 50 megapascal and 100 megapascal as figure 3.9 and figure 3.10, and combined loading bending 100 megapascal with a torsion 100 megapascal, bending 50 pascal with torsion 100 megapascal, and bending 100 megapascal with torsion 50 megapascal are applied for these numerical studies. Initial value of A and B are taken as 0.5, 1.0, and 2.0 mm are applied for all loadings. Figure show a cross-section of the geometry used in benchmarking model. After computing the stress intensity factor for the solid block, the results are compared with the analytical solution. The comparison show that the stress intensity factor for K1 mode obtained by using busy software is are in a good agreement from the result obtained from the empirical equation by Newman and Raju. Okay, for result for pure bending, figure point 5, figure point 6, and figure point 4.7 show intense stress intensity factor K1, K2, and K3 for pure bending loading and crack aspect ratio 0.5, 1.0, and 2.0 at the initial condition. It can be observed from absolute bending with 100 megapascal lead to the greater K1, K2, and K3 value. Stress intensity factor value increase when the bending loading are increased. For K3 case, the maximum value in 90 degree for crack ratio 0.5, 90 degree for crack ratio 1.0, and 60 degree for crack ratio 2.0. For K2 case, the maximum value in 60 degree for crack ratio 0.5, other 80 degree for crack ratio 1.0, and 90 degree for crack ratio 2.0. For all any cases, the larger value of K1 found along position along crack front. For pure torsional loading, figure 4.8, figure 4.9, and figure 4.10 show stress intensity factor for K1, K2, and K3 for crack aspect ratio 0.5, 1.0, and 2.0 at the initial condition. It can be observed that from the figure, absolute torsion with 100 megapascal lead to greater K1, K2, and K3 value compare the 50 megapascal. Absolute stress intensity factor value increase when the torsional loading are increased. For K1 case, the maximum value in 180 degree for crack ratio 0.5, 90 degree for crack ratio 1.0, and for crack ratio 2.0 are 30 degree position along crack front. For K2 case, the maximum value are at 180 degree and K3 are at 90 degree for all crack ratio. For this study, three different cases of combined loading were introduced. They are first bending 50 megapascal and torsion 100 megapascal. Second cases 100 megapascal for bending and torsion 50 megapascal. And then for third cases bending 100 megapascal and torsion 100 megapascal. Figure 4.11, 4.12, and 4.13 present value of stress intensity with a different value of loading combination and different crack ratio. It is shown from the largest value of K1 are found at combination at bending loading with smallest torsion. In all cases, the largest value of K1 are found at position 90 degree with has large crack depth. For all the any cases, the larger value of K1 found along position along crack front. It confirmed that there is no effect of bending on the K2 and K3 values as in the value coincident. Combination of large bending and large torsional load are resulting large absolute of K2. K2 has greater value on position under 80 degree. The largest absolute K3 value are found at 90 degree and 270 degree of crack. It's shown from any crack configuration. The greatest value of K3 are found at combination at large bending and large torsional loading. For the conclusion, pure bending, stress intensity factor for bending loading only affect at mode 1. For all any cases, larger value can be observed at bending 100 megapascal and the larger bending loading cause increased value of stress intensity factor for K1, K2, and K3. For the pure bending, the initial increment K2 value was soon to increase as the crack aspect ratio A proceed increase. At 180 degree for the given aspect ratio, the absolute K2 value were observed to be the maximum value. Meanwhile, for the maximum value for the K3 are at 90 degree. At 90 degree and 270 degree, the K3 value were found to have dominant contribution to the stress intensity factor, and for a given crack aspect ratio, larger K1, K2, K3 was observed in a torsional 100 megapascal. For the combined loading, combination of large bending and large torsional resulted large absolute of K2. K2 has greater value on position under 80 degree at 180 and 270 degree, the K3 value were found to have dominant contribution to the stress intensity factor. Okay, this recommendation for first analytically develop a generalized stress intensity factor equation based on the result provided in this work. Conduct same study with a multiple crack emanating from near the surface. Evaluate stress intensity factor and fatigue behavior under different variables, amplitude, loading block that the component may likely to undergo during service. Evaluate stress intensity factor and fatigue behavior under compensation torsion, professional and non-professional loading sequence. And finally, the result presented in this work may be validated with experiment finding. That's all my presentation today. Okay, thank you and have a good day.